Hey there, this is Arya Hakimian with C-Therm Technologies. Today we'll be going over how you perform measurements with the MTPS sensor and compression test accessory, or CTA. So in a standard MTPS test setup, you would first place your sample on top of your sensor, then place a 500-gram weight on top of that. Now the weight's simply used to help facilitate better contact between the sample and the sensor during your measurement. But where the CTA could come into play is in a scenario where maybe you want to apply a different amount of force on top of the material. Other than that, that would be available with the 500-gram weight. Or maybe you actually want to do a study and see how varying the amount of applied force actually influences the resulting thermal conductivity measurement. So an example of some groups or industries that we've seen gravitate towards the CTA to do those types of tests include anyone working with powders in the additive manufacturing space, or individuals who might be dealing with highly flexible or compressible polymer-based samples, such as those used in thermal interface material applications. It's just an example of where using the CTA and MTPS in combination can help provide more representative test data for the material and their overall application. So up next, I'm actually just going to go ahead and discuss the varying parts of the CTA and how it all works. We'll then get into actually testing a sample. So I'll load a sample onto the MTPS. I'll swap over to the software and we can see the data being collected and how that's all done. And the goal here will be to vary the amount of applied force across the individual measurements and see if we can get a change in thermal conductivity value. So the CTA itself has a base plate with a slot for the MTPS to fit into. So I'm going to pop that right into there like that. Get this stuff out of the way now. So the CTA, the main part you want to be concerning yourself with is the force gauge right here. This is what's actually going to give you your readout of the force that's being exerted on the sample during your measurement. That's done by monitoring the pressure foot in contact with the sample right here. So as you see, if I push up on the pressure foot, we get a readout on the monitor there. So we can change it where units we're working in, and for today's demo, we'll be working in gram force. On the back side of the CTA, there's this dial, and this is what's actually used to raise or lower the platform and bring your pressure foot and CTA in contact with the sample during your measurement. And lastly, say you're not necessarily interested with how much force is necessarily being applied to your sample, but how much the sample is being compressed by. Well, that can be monitored here with the displacement gauge. So you can turn this on, and then once you have your sample set up, you can zero out your reading, and then as you bring the CTA down and compress the sample, you can actually quantify by how much using the displacement gauge right there. So up next, I'm actually going to go ahead and load in a sample. So this is a very flexible polymer-based material, again, such as one that might be seen in thermal interface material space. So I'm going to place that just directly on top of the MTPS sensor like so. And now what I'm going to do is I'm going to bring the CTA down into contact with the sample, and we're going to see the readout change on the monitor right there. So we're getting very close, and so we just start to get a very minimal measurement of applied force. So this is where you'd actually go ahead and zero out the displacement gauge if you're interested in seeing by how much your sample is compressing by and how that metric is used to quantify the change in thermal conductivity. But for us now, I'm just going to swap over to the software so you can see what that looks like. Now on the Trident platform, you do have the option to test with different sensors, but for today, we're going to be working with the MTPS, and I've already gone ahead and filled out the rest of the test details. Again, we're looking at a polymer-based sample, and I've set it to run an undefined amount of measurements here, so I'll start and stop the test manually myself. What I'm going to do first is I'm going to go back to the CTA and actually just apply about 150-gram force onto the sample, just to get a little bit of contact there between the sample and the sensor, and we're going to start taking our first measurement. We'll view this as the baseline for the following measurements after. So the MTPS will go through the stabilization period before taking a measurement. This will occur on startup of the sensor as well as in between individual measurements What that's there for is just to simply ensure that everything is at isothermal conditions prior to taking a full measurement. So once the stabilization period is finished, it'll go into the measurement of the sample itself. And again, the actual measurement is only about 1 to 3 seconds in duration. So there we got the first data point being acquired, and we get a measured result of about, rounding up there, about 0.3 watts per meter Kelvin. So at 150 gram force, these are the measurements that we got. So I'm gonna go back to the CTA now and actually increase that to about 500 gram force, just to see if we can catch any differences in the resulting measurement. So again, it's going through the stabilization period, but the measurement will shortly ensue. And what you can see here is you're actually getting a readout of both thermal conductivity and thermal effusivity. Now, depending on the material or the intended application, one of these properties may be more valuable, but regardless, the MTPS does report both of these for you simultaneously. So again, just finishing up that stabilization prior to taking the next measurement. So the data is being acquired, and going from 150 to 500 gram force, we do see quite a significant jump in the measured thermal conductivity value. So I'm going to actually go ahead and increase the CTA one more time to about 1,000 gram force and just see what that third measurement would look like. You may be noticing over here on the left that you're getting a visual or a graphical representation of the measurement as well. So this is the measure of temperature rise over time at the sample sensor interface. With the MTPS, there is no need for regression analysis or any post-processing of the data on the user side. This is all taken care of for you with the software, but it does provide you a visual representation of what's going on. But again, the data and the results themselves are simply populated in this table over here. Also in the table over here, you do get a readout of the temperature or the sensor temperature. So you can use that to help quantify what temperature your tests are being performed at, and can provide some very useful tool, especially if you're doing elevated or subambient testing in a thermal chamber, let's say. You can help monitor and make sure that the desired temperature range has been reached prior to initializing your measurements. So then we got our third measurement there at 1,000 gram force. So again, we do see a change, again, another increase in thermal conductivity, maybe not as significant as that first one, but still, again, enough to catch a noticeable difference between the measurements. I'm just gonna stop that there. So again, this was just to help demonstrate that by changing the amount of applied force, we do see an overall change in thermal conductivity. This is just an example of how the CTA can be used to provide some perhaps more representative test data for your groups and your applications. I did mention, again, there's the powders, thermal interface materials groups do find the CTA quite useful. Also, if you're working with textile materials, especially those concerned with testing according to ASTM D7984, it's an international standard for quantifying the warm feel and cool touch of a material. This actually does require you to use the MTPS and CTA setup to get a valid test result. So again, depending on the materials that you're looking at, their overall application, being able to use a CTA and apply varying force loads can provide some beneficial results for your groups. So with that, I'm going to close this out. Again, if you had any questions or wanted to go a little deeper into some of the testing that can be done with the CTA, feel free to reach out and we'd be more than happy to help.